Sup, Tyler?
Hey Angel, you got 7 minutes before we start. I'm gonna set up your documents and stuff so we can get ready. This is all review week, so this shouldn't be too bad.
Okay. Mr. Tyler.
Yes, sir. Yes, sir.
I can turn off my camera until the thing is done.
So you turn off your camera to what?
I said, can I turn off my camera until the 6 minutes are done?
Yeah, yeah. As soon as it starts, you gotta turn it back.
Alright.
All right, we're gonna get started in about 2 more minutes. Let's take attendance real quick. Actually, we're early. That's why I said that. I was wondering why I said yeah, you can use your camera. So 2 minutes, Andrew, you gotta keep your camera on, but pretty much everybody's gonna be marked late in 10 more minutes, which you'll get a head start. All right, it's now 10:10. In a minute, Angel needs you to turn on your camera and leave it on because class is now starting. But there's a grace period of 10 minutes. You want to use this time to set up your document. And since it's a review week, bear in mind that the assignment you might already have in your notes. At the end of this review week, there will be a makeup quiz for almost everybody. So take a moment, look at the problem in class in ESB, and at the end of the 10 minutes, we're going to go through our norms too. But we're going to mostly talk about problems from last week because a lot of people haven't turned any in. So all this week is like a makeup week. Review problems galore. And you'll notice if you find a problem in your notes, if you've done it with us, you'll see that they're very similar. So we're going to go through it together, and it's a lot of.
Wait, I have to keep my camera on?
Yeah, you got to keep it on for the entire time. Class has started. The only reason you can turn it off early is you was early. So you got to keep
All right. Wait, why you put 10 minutes? You put 5?
I'm sorry. Okay, who is this coming in the room? Lisa is here. Cool. So just getting set up, Lisa. I think this week is gonna be pretty easy on you, and we're just going over problems from the past because the quizzes didn't look all that great.
Yeah, because math is horrible.
It's okay, but you're gonna see a lot of these problems again. So this time around, you know what to pay attention on, and I'm thinking we're gonna do on Friday. I'm gonna go through one of the problems to help you guys out, and you guys, the class, got to choose which problem to tackle for you out of those 7 problems. But pretty much you're gonna see all of them. I think one of the questions did it have no. I left the graph problem out this time, but that graph problem is coming back again tomorrow. So you guys got to get used to the spreadsheet. I don't know if you bookmarked it. I told you how to bookmark that spreadsheet we used last time to do that graphing. We had another situation like that tomorrow. Position and time graphs. Okay, who's coming in the room now? Courtney Dixon has arrived. Okay. So just about 7 more minutes before the grace period is up. We're going to start our norms and everything. You want to name today's document?
I'm gonna give you something to snack on.
What did you say, Angel?
I'm gonna give me something to snack on.
Hurry on back. We're about to do our norms in about 5 more minutes.
Gotcha.
So name it, of course, the same format where we got a header. It's the 28th. Oh, man, September's gone. It's almost October. Period 3. I'm sorry, 2. Second. This is physics. So wait a second.
Oh, Mr. Tyler, I got
Go
a
for it.
question. I was gonna ask, is binary only for computer science?
You mean binary messages?
Yeah.
Not exactly. Binary can be used for a lot of different things, not just computer science.
No, I'm talking about like for that class and not other classes
So wait, you
that
talking
you have.
about? You know which class you talking about? You talking about computer science for all or robotics?
Yeah, for computer science. Is it only for computer science? We can't do it in
We
physics?
can, but yeah, I was trying to get the basics out the way. So we can program some things for physics.
Oh,
To answer your question, yes. But I think Miss Lane is going to be starting a girls' code group. I'm going to try to get the guys on some coding. So if you're interested in that, definitely ask her about it. Okay. Everybody should be logged into Edsby, and it's the same setup where I think what's the problem today? It's about power. Oh, average velocity. Yeah. So remember to create your document and then copy the problem over to your Google Doc. Get that stuff out of the way so you can be ahead of the game. And then just pay attention to what you think the known and unknown values would be. How much time we got left before I gotta do it attendance? 2 more minutes. And I'm do attendance, and then we're get ready to do our norms. Somebody else is making it before the buzzer. Who is this? Looks like Leah Mims. Okay. And someone else is coming in. Okay, Leah's here. I was just about to do attendance. Who else? Jacqueline made it. Okay. All right, so let me do attendance real quick. That's what I was waiting on. All right, so Alande Allen not here. Lisa Brown is here. Jacqueline's here. Mario's not here. Christopher Clark's not here. Courtney Dixon is here. Mr. Garcia's not here. Romel Lee is not here. Rashad Lockhart's not here. Angelique's not here yet. She's been here before. Aaliyah Mims is here. Angel's here. The Thick Pin's not here. Wallace is not here. And Worthy is not here. Okay, so about 2 more minutes, you should be establishing a document like I have, a Google Doc. We're going to go into the problem today after we do our norms and discuss the agenda of how we're going to go through the class. I got to recycle this. Share that to the office. Ooh, what happened there, buddy? I lost my class. No, I thought something went wrong. Uh-oh. I hope not. There it goes. The view changed on me. Okay. All right. So a minute left, you guys. As a reminder, all of your cameras should stay on the entire time in class, or it will affect your grade. I mean, your attendance score. Uh, okay, somebody just put something in the chat, I think. Getting your phone. What did she say? Hold on. I'm getting my phone fixed at the moment, so I won't be able to talk. Okay, okay. Thanks for the heads up. So I'm not just calling on you when we're doing the norms, Jacqueline. I hope you can get your phone fixed. Did you ever get in touch with Mr. Irvin so he try to help you out with that laptop microphone thingy, or no? Okay. So now next steps is we do our norms. Where are they at? Here they go. All right. So I'm calling each of you to do a norm until we have all 10 completed. So let me open this up and go to the very top. So the 5 basic norms. Let's start with who's in the list. Aaliyah Mims, can you read number 1? She's moving around the camera. See, she's there. You turn your microphone on, Aaliyah.
Can you hear me now?
Yep.
No one has the right to hurt another person.
Thank you, Miss Mims. All right. Next is Angel. Can you read number 2?
It smells like straight, what's it called? Onions.
Aaliyah.
That's all I smell, onions and spaghetti. Oh, y'all still give me my bed. I'm sorry. I'm trying to mute myself, but it won't let me. Can you mute me?
Yeah, I got you. Give me a second. She's still talking. Angel, are you there? No. Okay. Let's go to Courtney. Can you read number 2?
We will never behave in a way that discredits ourselves, our school, or our family.
Uh-oh. I can't mute her. How about that? All right. I'm going to come back to her. So let's see. Jacqueline, can you do number 3? Leah, I'm going to have you come back in the room because it's like, it's not letting me mute you. Okay. Okay, go ahead. I'm going to bring her back. So was it Jacqueline, did you do number 3? Or was it Courtney?
I did.
Okay. So number 4. Jacqueline. Oh, you can't speak. That's right. Lisa, can you do number 4?
Yeah. An Excel Academy and Southwest student is always a lady or a gentleman.
Okay, and let's see. Angel, are you there? Nope, he's not back yet. Courtney, can you go ahead with number 5?
We take pride in the Southern Academy and Southwest.
Thank you, sir. Let's see here. We got Jacqueline, you can't read. Lisa, can you just read all 5 so we can get into the assignment?
Yeah. We respect the opinions of others. We respect the coach of the classroom. We are attentive and participate. We have high expectations of ourselves, our peers, and ordinary endeavors.
Okay, thank you, thank you, thank you. Okay, so let's go through this slowly. Everybody should be in ESB, right? Yeah, I know, Lisa. Right now, I gotta try to get her back in the room. Trying to text her in ESB right now. So everybody, copy the question over this question here over first, and then we're gonna go through the agenda. But you need to take both questions. You got a synchronous part and an asynchronous part. So put that here. Work on doing that while I try to get Mims back on the line. What was her microphone? I muted it, it came off of mute. I was like, what? Unless she got the mute button held down or something. Okay. Let's see, Aaliyah Mims. Cheers. There you go. Send her that message. Hope she gets it. All right. Now, what was I about to say? So we got to also talk about what today's title is, and who knows what that would be. You put it in the chat, or I guess you could say it. Oh, Angel.
Sprint training review. Average velocity.
Thank you, sir. So, as Courtney said, it is sprint training review, and it's average velocity we're talking about. Oh, Lisa got it too. So let's put that in our title. So it's sprint training. You can actually copy what Lisa put in the chat. Sprint training review, right? And then the word or the classroom term today is in the brackets already. So that's average velocity. All right, we're gonna center that because that's a title. Right, that right there. Now we're gonna go through the first problem slowly. Let's space it out. And what we want to do is, last time we made a drawing, right? If you don't remember, go through the steps so you can remember how to do this drawing, because it can help you out as far as points. The drawing needs to be in there because you have to illustrate your problems. And then you'll see us slowly move into simulations again. So this is just a review. If you already got the notes, then you can use your notes from the past to finish the problem off. But if you don't, pay attention. So let's go through it slowly, right? We first want to go to insert. What was that? Okay.
I'm sorry, that's my baby cousin.
Oh, you back? Okay. So go to insert, drawing. You're going to do new. And if you remember, we had two situations. We had, let's draw a line. So we had this line, which is a track initially when you had the runner, right? And then you also have this track with the runner walking back. So we had two situations, one with the runner running, or sprinting, I should say. And then we have one where they're walking back after their sprint. So we're going to name this section right here sprinting, or sprint velocity. Okay, and then I'm going to take this and put it again down here, because now this is the walking velocity. Okay, so now that we have our two situations, we want to use some boxes to try to draw in like our two characters that's moving around. Before we do, let me save this so you'll see how it looks. We can always come back to it and edit it here and finish drawing. So just get this part done. But I'm gonna put it in the chat. I think Angel's back, so I'm gonna have him read something. Angel, you missed the norms, dude. I was like, where did he go? Where is it? Edsby. And let's put this in here. And Angel, I would like for you to read what's in the chat. Welcome back, Jacqueline. So can you see it, Angel? Is he there? I don't even see him. Oh, he's back. Okay. Angel, can you read what's in the chat, sir? Keep disappearing on me, man. Now you got a towel over your camera. So can you read what's in the chat, Angel? You gotta turn your mic on, sir.
Say what?
Can you read what's in the chat?
It's too much. Hey, bro, shut up.
Okay. You got it?
Child, I could barely hear you.
I was asking you to read what's in the chat, but it's cool. Take a moment to get yourself together. Courtney, can you read what's in the chat?
Hello and good day to all future physicists. Please remember that all secondary problems need to be completed and ready to present tomorrow in class. Secondary problems have to be completed as homework and will be checked tomorrow in class as well.
Thank you, sir. All right, so let's move on. Who did not get? Jacqueline, you still can't read, right? Because your microphone is dead or something? Or your phone's dead, I think. I think that's a no. She can't. I see your camera's on. All right, let me put this next section in the chat. And Lisa, can you read that one? We'll come back to Angel and see if he's together.
Please remember to get maximum credit. All calculation/steps for the final answers to the problems need to be uploaded to SBDSA, the same format that we have been using since the start of the quarter. This format is shown in the video. Type the Google Doc, convert it to PDF. Stay safe out there and Zing.
Okay, thank you, Lisa. So last thing is the problem. Let's see here. Jacqueline can't read. Angel, can you read this next part? Let's see if he's got his situation a little bit more calm. So no. All right, he's still got to get. I'll read it. So the first problem, and you might want to copy this problem over if you haven't already. Let me close this window. There we go. So the first problem is an athlete sprints 62.3 meters in 9.2 seconds, stops, and then walks slowly back to the starting line at 8.8 seconds. If the direction of the sprint is taken to be positive, meaning they're going in the positive x direction, and then the walking distance will be in a negative direction, going backwards. So that's what I was trying to get you to draw initially. Make sure you put the problem in there, and let's come back to this drawing. So we got two situations. Let me expand. I said earlier, and then I'm gonna go back into my drawing. So now that I have this set up, the next thing I want is to create a shape that represents my sprinter. So I'm gonna go to image, and then I didn't want to do images. I don't have any images I want to put in there yet, but shapes, that's what it is. Go to shapes, and then let's choose something new. So we'll call this, I don't know, I'm just choosing something. You can choose something as well, as long as it's a little different. So choose a little hourglass looking thing, and then you just click and drag, and you create the shape. So this would be the sprinter, right, when it's starting to run. Now, the next thing is you want to give direction as to where the sprinter's going. So I'm going to draw this arrow, and he's going that way, and that's what they mean by the positive x direction. So what are our values? Well, this is, for the sprinter, we got to know x is equal to 0, because he's starting at the beginning. So we're going to put this here, and x is equal to 0 meters. Okay. Span it out, and it's going to come up some. All right. So that's that one. But now we got to do, and I remember we talked about final and initial. So that's coming back again. So we're going to say, copy this box, and I'm going to make another one and just bring it over. Okay. Now this is, remember, your final, your initial. position, right? So what do you think this is going to be? Well, this is however many meters they went. So let's come back to the problem. I'm just saving it for a second. We'll come back to this. But how far did he go? So it goes 62.3 meters, right, in 9.2 seconds. Stops. That's the sprinter's part. So to get that, we got to make sure this final position is going to be 62.3 meters. Okay, so I'm going to come down, edit, and then we're going to go back to this box if you've made it already. And this is going to be 62.3 meters. And this is your final position. Okay. There we go. All right, so I'm just going to clean it up for you a little bit, but in essence, that's your first two known values in this problem. So this will be xi and this will be xf, and I'll show you how to subscript it when we do go through the problem. The next one is what happens when the walker or sprinter is running backwards. Okay, so what are we going to do? We're going to pick another shape. So we go to shapes, and then we pick a different shape because we're going backwards now. So I'm just going to choose this box, and then I'm going to draw it by clicking and dragging, and there's that box. Now this box represents, again, the walker going back from where they ran. So we're going to take another arrow. I'm just going to copy this one. And if you don't know how to do it, you can also go here, click on the select line, go to arrow. All right, so I'm going to grab this arrow, and remember, if you're doing this, you can always rotate your arrows. So this is going this way, right? And you can stretch it out too. So this is a slow walk back that the runner's doing. And now you see that both of the vectors in their direction. So what are we going to do next? Well, we got to put in our metrics for this. Now this down here is going to change because it's not going to be initial, right? The initial is going to be when he's walking back, and that's going to be however far he has come back. So let's copy this and come down, and your initial position is now over here because they're walking back now. Your final position should be the duration that you need to go back. So let's copy that. And there we go. You should have this much already generated. Okay. In a minute, I'm gonna ask people to share out their screens to see how far they've gotten. But let me make sure we got all the parts of the problem. So
I'm still following along.
you still following along, Angel? Okay. Just make sure you have it typed up so you can show your working.
Yeah.
Okay. So we got our initial position, our final position. Remember, it changes because you got to go backwards now, right? Clean that up because it's like equal sign. It's certain small things you bother me, so put that there. Okay, so I'm gonna save and continue, and that's the first, sketch that you need that shows what happened in this problem. You need this in your problem to get credit. So another thing is, with this image that you created, you want to click on wrap text, and this allows you to move the image around freely. If I click on the image, I can press the up key or the down key and move it around. If you don't click on that, it's going to do what it wants and just find space. So just get in the habit of doing that. Okay. So now I can move on to the problem part, right? And I bet you're wondering, well, what do we need to do this problem? I'm going to shrink this down some because it's just too big. It's on top of my 1S. I didn't want that. Bring it down some. Trying to get right on top of 2S. There we go. Good. So this is the 2A, asynchronous. Did it go down some more? Okay. So let me zoom out so you can see the entire document. And you should have this set up. So you can resize it if you think you need more room, like I did. And now it's to the point, like, what do we need for this problem? Now, this is the opportunity point moment. Who has notes on this problem from the past? Because if you have notes, you can tell me what. Did you put your hand on Lisa that fast? I thought this was one of the problems you said you didn't know how to do.
No, we took notes before,
Yeah. Oh,
but I didn't know how to do the problem.
so you have notes on this.
Yeah, I could type it in chat, see if I'm right.
That's what I was going to say. Copy what you think I should do first. Like, far as what are the main notes or the mathematical notes I give you in the center of the page? Do you have that much? So if you have it, just copy as much
Yeah.
as you can to the chat. I'm going to see how much you got right. This goes for anybody, though. And if you put it in the chat as a time stamp, so you could beat the buzzer on Lisa if you can. But I don't know. She kind of quick, man. So Lisa, God, she got it. Yeah, she got it. So everybody remember this? Delta function. Very good, Lisa. So you got a head start on it. Okay, so let's see what she got right. Xi is 0 meters. Yep. Now you have two parts, right? You got do the Xi, XF, and Ti and TF for the walker and for the sprinter. So you got the sprinter here, and that's correct. But what about these times? You should know at least the sprinters, right? So let me take what Lisa has and I'm gonna put it right into my paper because she's absolutely right. The first part, and this is how you guys put it together. Very good, Lisa. I was like thinking they're not listening to me, but they are. All right, so let's put this in the center. If you don't remember, this is no, and again, this is all review. But as much as you can give me, you get some of your points back. This is why you should have been paying attention. So this is the next step of the problem if you didn't know. I'm just gonna clean it up a little bit. And this is what Lisa gave us, right? So she said, hey, xi, we got to clean this up, right? So xi, we're going to subscript it. This is what you should be doing, everybody. So I'm going to format. And remember, subscript drops it down so it's a mathematical representation. This is, you can put big X here, and you got to subscript that F because it's final. So that's going to be, let's see, format, subscript. Okay. And you do the same to these. So I'm just gonna go ahead and do it, but we're missing some explanation up here. And I'm gonna clean this upstairs too. But again, you should be doing as I'm doing, editing your document. So you can be like Lisa next time and just have it ready for Friday. Every Friday there's a quiz. And we got midterms coming up too, y'all. So those progress reports are soon gonna be coming out. If you don't like what your grade is, you have every opportunity right now to fix it before October hits. So that's why I'm doing this week of review. I want to expand this some more because it's so small. There we go. And then probably change the resolution. There we go. So as you can see, these are subscript values. Lowercase t is always usually seconds. Now I'm going to clean this up, but let's put in some values so you guys can get going on this, right? 62.3. Remember, we said it in our diagram. That's why I had you do this. You have initial position, that's xi, that's 0 meters. Final position is xf, it's given. So that is 62.3. So I'm come here and say that's 62.3 meters, right? What about time? What's our initial time? Well, if we started at 0 meters, we gotta also start when there's no time, right? And they give you a time frame of when it ends. And that's 8.8 seconds, if you see the problem here. Okay. So I'm come down here, and that is 8.8 seconds. I'm sorry, that's 0 seconds and 8.8 seconds. All right, so far so good. What is the sprinter's velocity, right? Or average velocity? It's a big unknown. And, you know, for a sprinter, you usually capitalize that. But so we're going to say sprinter. And then when you say average velocity, we write it as V, like she has above here, but you just gotta, you know, subscript some things. So VAV, like Lisa put up here, and I'm gonna subscript that. There's nothing that you're confused about. You're just doing literally what I'm doing. If you're doing it in class, it's easier on you tonight. Okay. So what is that going to be? Some number we calculate in terms of meters per second. In case you forgot what velocity is measured in. Now, this here is missing some things, and I'm going to clean it up for you. So she's right. That's the equation for distance over elapsed time. But what does that mean? Well, we got delta, and she has the right triangles, but we got to subscript that. Because you got to go to, if you don't know how to do it, you go to insert, special characters. If you try and get that delta in there. And what you want to do is click on this for math. I'm waiting for it to populate. And then just type delta in the search. You can get any delta you want. Make sure it's just a delta. It looks like, it says what they are if you don't click on it. You can highlight it. So we want that Greek letter delta. But all I was doing here is subscripting this because that's the way it's supposed to look. Okay, and then the same thing for this. What else? We got this one. So if you're wondering why am I doing all this, because this is the way you get full credit. You make sure it's edited the same way. Yes, Miss Brown.
What is the 9.2 seconds for then?
You said 9.2 seconds in the
Yeah.
above problem. 1 second. Let me look.
Yeah, the first.
So, ooh, that's my fault. It's 9.2 seconds, Lisa. Thanks for correcting me. That's for the Walker, the 8.8, right? You're getting the hang of it. So this is 9.2, everybody. Sorry about that. I'm thinking ahead about the Walker because there's two parts to this, right? We got to do. One is the sprinter's average velocity, and then it's the Walker. So let me put that in here so it's not confusing. Great catch, Lisa. So Walker, right? And what is a Walker? Well, it has the same type of setup, but there's some things changed there, right? So this is going to be for, you just make another one for Walker. And we put the in there for Walker. There we go. All right, so this is 8.8, I think, right? This time frame for with a walk back. And instead of this being 62.3, 62.3 actually is your initial, right? We gotta look at our diagram and remember that. And this becomes 0. That's how that goes. Great job, Lisa. All right. So it's part A, find the average sprint velocity. It's this section here we drew. And then part B, find the average walking velocity. Is this part here at the bottom. You should have this diagram in your document. Okay, now, I think I was rushing to get back to cleaning this up, and Lisa helped me out with that. But I don't think I told you everything that's inside of here. So remember, XF is like saying final position, right? So let's spell it out. That's going to be final. This is explaining your average velocity, right? So inside of it, you have final minus final position minus your initial position. XF minus XI, right? And then this is going to be divided by your final time. So time final or final time subtracted by the initial time. That's all delta means. To say delta, it's this here. That's one part of the notes. I don't know if you guys had or not. Okay, so this is delta x. Put the bracket around it. This is delta x. And what it means. And this is delta t and what it means. Courtney left. I hope he's coming back. Okay. Oh, T. Sorry. So when we put all this together, we now have a situation where we can calculate each. This is your part A value. And this is your part B in the problem. Okay, I come here and do it. So let's start calculating now. Let's start with the sprinter first, right? Or part A value. In part A, we just use the average velocity calculation, which is this here. Now remember, delta just means it's final minus initial. Final minus initial, you got delta x and delta t. But we're going to take this equation here and just plug in the values to solve it. How are we doing on time? So it's 10:10. We started at 10:10, so it's 10:48. Oh, I gotta move a little faster. Okay, so we're not bad because we get the drawing out the way. We got our knowns, we got our notes. Thanks to Lisa. But let's finish up, right? Because I got a few announcements to go through and talk about where the videos are and make sure you guys are straight. But we put this equation here, and this is like our strategy portion. Let's say strategy. This is where you plug in the values. Everybody's favorite part, right? So we come over, and what we put in here is what we have for our sprinter initially. So what is XF? XF was, what did we say, 62.3. What is XI? That's going to be 0. Right? And these are meters, by the way. Okay, meters, meters. And then what goes in the bottom? It should be very obvious. It's in our knowns. So that is going to be 9.2. And this is going to be seconds. And hello, Mr. Irvin. This is 0 seconds. Ooh, it shrunk. Do you have a GGI link for them, or? Yep, you sure do. Yeah, I'm going to take a moment and get the link from Mr. Irvin. He just dropped it in the chat for you. So that's to get to GGI. We're going to bring this up. So wait, seconds. There we go. So what does that translate to? Well, it's real simple. I mean, if you had another value, you'd put that into 0, but we don't, so we don't have to worry about it. But it does shrink the equation down to where you just have 92 seconds, right? Seconds divided by, well, 62.3 meters divided by 9.2 seconds. We can simply figure that out by putting it in our Google Calculator, our Symbolab, or any device you want to use. I'm just going to take these out and put it in the right form. This removes and goes over here. And this too removes and it comes over here. So you end up with just these two. And then lastly, we just divide these two numbers, which is 62.3 divided by 9.2. I can copy this entire thing here and have it calculate for me. Remember, in Google, trying to teach you guys how to use your internet correctly, especially as scientists, you just make sure you put equal sign and it'll copy what you need it to copy. So in this case, it's 6.77, and that'll be meters per second. So it'll be equal to 6.77 meters per second. Right now, I'm going to bold this and underline it because that's part A done. Well, not underline it because I did something wrong. But that's one part of the answer. We got part A here with the walker. All right, it's 10:51. So let's hurry up and do this one. What do you do here? Well, it's the same situation. So we just take this strategy, right? And then I'm going to come down here and I'll put everything back, but change the values. Remember, there's some things that changed here. The time and your starting positions. So instead of 62.3 going here, it's going to switch with that 0. Take that from there and replace it here, because that is your initial position. If you look at your walker's known values, 0 meters here because we're trying to walk back to the beginning. Now, in this situation, it's same because your time starts at 0 and it also ends at a certain time frame. So you just keep that as 8.8, right? Let's change it up some more. It's going to be 8.8 because the seconds will drop off. This is not going to be just 62.3. It's going to be minus 62.3. Okay, he is going in reverse, and then to get the final answer, we got to divide it by our negative 62.3 by the 8.8. So let me put this in correctly. That'll be what? a step before this where you combine them. There we go. So now, like I said before, this seconds comes out. And it goes over here. And then before it, it's going to have meters. That's just the dimensions measured in. And that goes here. Okay. So in essence, this is gone. No meters, right? I'm just bringing it closer so we can divide it out in the end. And this just means meters per second. You see M over S. So what do we got? Well, let's see what Google says it's going to be. We just make sure we take the equal sign and parentheses of the way it's set up so you can calculate it. And we hit enter, and we get negative 7.0, let's say 8, because there's a 9 behind that 7. So a negative 7.08. It's equal to this. I shouldn't have did that step. Hold on. Leave that there. It goes here. Negative 7.08, and that's meters per second. And that class is pretty much all there is to it. It's 10:54. Got to go over a couple of quick things. Wanted to give you guys time to, get this all jotted down. We get out of here at 11:10. Is now 15 minutes left of class. Do you need me to scroll up or down so you can get the notes, or did everybody catch that?
Can you go to the sprinter?
Okay, one second. So the sprinter is this here, the known values and stuff?
No, the strategy.
Okay, the strategy.
Thank you. Oh, Mr. Tyler.
Yes.
I was also asking, can I go back and correct my old work and turn it in?
Yeah. Yeah, you can actually.
Okay.
You just got to let me know which ones you did, because it'll show up as done already, and it won't let me know if you did it new, you know what I mean? So just,
okay.
You're usually good about it, Lisa. Just send me a message. Hey, check this assignment, Mr. Tyler, and I'll go and take a look at it.
Okay, thank you.
Mm-hmm. You need me to scroll down, anybody? Did you miss anything? Okay, while you're thinking about that, I'm going to grab up the word of the day and stuff, because you guys, we forgot to do that part. And today's word of the day is, I think it's apex, right? So at the very top of your document, right after the title, you're going to type word of the day is, and then for today, it's apex. Y'all need to take advantage of that, because I think Lisa has been. Classroom, I've been seeing most of the work she's been doing. Classroom term of the day is, and if we look at today's term, it's in the brackets, right? Average velocity. So in order to get the 25 points here, this is worth 25 extra points. Make sure that's known. Help you guys out. You need to at least have the definitions of each. Okay, so you just got to look up the words and put the definitions right by the words, just like I've done. So I shouldn't just see apex and average velocity. I should see the actual definitions if you guys want those points. The other big thing is, now that I talked about that, let me minimize this. Don't forget there is a Facebook drawing, okay? A few people have been taking advantage of it. What is going to happen is you're going to look at all the different entries. What you do is you go in there, you talk about which teacher, basically introduced you or told you about it. And you put your name on there and subscribe. And this is our Facebook page. I help edit it and everything. You will possibly get $100 at the drawing, which is Friday coming up. So if you need help getting to that site, just let me know. But it is on Facebook, and it has that logo. So just a heads up. It's 10:58. I think I talked about, library. And there was one other thing. Library is where you see all of the videos, right? So if you see a link by the camera, that means a YouTube link. And you can use that to go back in time and see maybe what we did in the assignment wasn't clear. YouTube links I try to have and videos all ready by 4 p.m. every day, and it'll be inside your library. Last thing is, what do we see? It's kind of like Lisa said. You definitely want to go to my work. It's hard to do from my view, but from your view, it's my work. Go to assessments and see if there's anything you got to do, because we're running out of time where you can make up stuff. So please log in and into SB and go to my work and see assessments to see how you're doing. Start turning in this work. There's no reason to fail. We got, I think, 12 more minutes of class left. Okay, guys, once you have a break to get ready for GGI. So did everybody get the GGI link in the chat? Yes, no, maybe, possibly.
Yeah.
Okay. So make sure you use that to get in GGI. I'm trying to look at the list right now. I don't know if you guys know, but I'm also doing SAT prep for certain students. Let me see if any of you guys are in the list. I don't see none of you guys. I got Jacqueline. Jacqueline's not on that list. No, these are all seniors, really. And none of you guys are seniors. All right. So, so basically, at this point, you're free to go and try to stretch your legs and get ready for GGI. Please participate in GGI because I do take notes, and that is another form of extra credit. All right. So I think it starts at 11:15. Otherwise, you're free to go if you have no more questions for me. Don't forget that link.
Okay.
All right. Take care. You guys make sure you do your asynchronous problem too. It's similar to the synchronous problem. Got questions, Angel? Or you just hanging out?
No, I'm going.
Okay. All right.